Thank you very much. So I believe most of our audience here are already very familiar with the concept of digital twins. And indeed, this particular topic has been such a hype in the last few years. So most of digital twin discussions actually focus on success stories and the cutting edge features. But I think for this particular session, we would like to talk about some of those remaining challenges, especially with regards to the data capturing that we have observed in the last few years. Next slide, please. Okay, so agenda-wise, we will quickly run through a quick introduction of our company and some of the projects that we have worked on in the past. And after that, we are going to basically dive deep into the data capture gaps, as well as some of those solutions that we have provided so far to address some of the gaps. I think overall speaking, there are a lot of opportunities still in the areas of data capture, and I will leave a few final comments on that particular point. Yeah, next slide, please. Thank you. So quick recap of what spatial digital twins are. Spatial digital twins are virtual representations of real-world objects. And generally speaking, this is a very common framework. What you are seeing on the screen right now over here is a very common framework that a lot of companies have been referring to. There are 5 levels of spatial digital twins. The first level is regarding the 3D replica creation of the spatial digital twins. And the second level is regarding contextualizing of the real-time data or historical data into the 3D space. Level 3 talks about the data analytics, mostly happening from the data perspective. So you could, technically speaking, you don't really need a 3D to do this kind of predictive analysis. You could do this purely based on the data or mathematics model. But because some of the customers are looking into an overall centralized control tower through digital twins, so sometimes they would want to integrate the level 3 digital twin into the overall digital twin dashboards. So sometimes we do incorporate these kind of dashboards into the spatial digital twin. And level 4 is the comprehensive twin, which is usually the more complex kind of scenario. It's quite difficult for human beings to understand the different parameters we may need to deal with. So in this case, we usually will run simulations, and from there we try to pull out the parameters based on the simulations for further analysis. And level 5 is the autonomous twin. So based on what is learned from level 1 to level 4, we try to influence the control in the physical environment. So for example, the control of robotics through fleet management system, or the control of aircons, smart building control systems, and so on and so forth, to really complete the loop, to ensure that digital twin is not just happening in the digital space, but also making sense in the physical environment through actual control. So that is a high level of spatial digital twins. I think the frontier of spatial digital twin nowadays are already at level 3, level 4, level 5. There are a lot of hypes, a lot of discussions going on in terms of level 3 to level 5 kind of innovation. But actually, the kind of innovation we're looking at, there are still a lot of rooms of innovation, still a lot of long tail use case scenarios at level 1, level 2, which are yet to be covered. So I think in this session, we're going to talk more about the level 1, level 2 gaps we've observed in the last few years. Next slide, please. Okay, so quick intro of Hiverlab. We are a company which was founded in 2014 in Singapore. So we are in the business for about 11 or 12 years already. And most of the solutions we provide nowadays are categorized under the big term of spatial intelligence. Most of our customers come from the sectors of logistics, manufacturing, built environment, medical health, smart city, and critical infrastructures. We are currently serving hundreds of customers coming from 20+ countries, and we have a wide range of collaboration partners in our network to deliver projects together. Next slide, please. Yeah, so one of the core products right now is called Spatial Work, and it is a platform designed to make digital twin creation easier for our end customers. So Spatial Works was designed with the level 1 to level 5 framework you saw just now in mind, and we are providing a 3D media library which allows users to create the 3D digital twin, and we allow users to incorporate the different kind of data dashboards into the digital twin for data visualization and analytics as well. Next slide, please. Okay, we have served a lot of customers over here. These are just some examples. We have done simulations in built environment. We have done real-time monitoring in warehouses, smart cities, ocean ports, shipyards, manufacturing plants, so on and so forth. So most of the use cases have several kind of value proposition for our end customers. Sometimes the customers are approaching us to automate the solutions to improve the operations. Some of the customers are approaching us to improve the product design based on the 3D simulation. Some of the customers have a specific focus on safety, or some of the customers may approach us to improve the sustainability reporting they have on in their very facility. So all of these are projects we have worked on in the past. And the key topic today regarding the data capture gap is actually a learning point based on all the different kind of projects we have worked on in the last few years. Next slide, please. Okay, yeah. So data capture methods. If you recall the level 1 to level 5 dashboard, the overall framework we have shared earlier, you'll recall that at level 1 and level 2 is where the data capture happens most of the time. So when it comes to 3D data capture, there are many ways, including things like geospatial data coming from GIS platforms or from satellites, sometimes the customers may be using technical drawings to showcase the 3D model they have for a specific building or for a specific manufacturing plant or specific warehouse. For certain sites, the site may already be commissioned up and running. So in those sites, the customers may want to capture the 3D model based on the 3D scanning. And most recently, as some of you guys may know, there's also a new solution called Gaussian splatting, which is one of the latest web-based 3D volume or like rendering solution, which is quite fast. So those are regarding the 3D content creation, and there are multiple ways to do so. Based on the end customer's requirements, we may need to suggest a different kind of 3D data capture methods for the customers. But aside from the 3D simulations, there are also solutions out there to capture other type of data. So we have been working with partners coming from different industries to provide these kind of solutions to our end customers. Sometimes our customers might be looking for electricity meters, water meters, or indoor air quality meters, so on and so forth. We have IoT partners for that. Sometimes the customers might be looking to say a logistic or manufacturing solution where they need barcode scanners or printers and so on and so forth. So we have partners for that. Sometimes we are working with partners who are providing cameras, security cameras. Some of them may already be providing their own video analytics solutions. So in that case, we don't have to provide the VA solutions for our end customers. We just have to provide a platform for integration and visualization. Or for certain cases, if there's certain data out there the customer would like to have, but it's quite difficult to gather such data upfront, maybe we need to run simulation upfront to generate some of those data as a baseline for the customers as well. And I see we have like 50 plus audience in a session right now, and I believe some of you guys are also quite experienced with some of the other legacy systems in the enterprise environment as well. So in some of those projects I've shown earlier in a portfolio slide, we deal with systems such as the warehouse management systems, automation management systems, energy management systems, and so on and so forth. So it is true that through spatial digital twins, we are trying to break down the silos of different systems, and we're trying to capture the data in many, many ways. However, now move on to the next slide, please. Yeah. So, however, we do believe that there are still a lot of data capture gaps, which is actually the main theme today. So in terms of the IoT sensors, there are niche use cases where existing sensors may not be suitable for such scenarios, or such existing sensors may be too expensive for some of the customers who have a specific pain point but may not have a big budget to afford the very high-end kind of sensors, right? Or there are certain use cases we've observed in the urban survey domain where the customers are usually not quite sure what kind of data they may need eventually, but every time they deploy the team to try to capture the data, it takes up manpower, it takes up time. So they basically face this challenge of a more automated way of capturing such data during urban surveying. And also when it comes to simulations, although there are this common practice of running simulations nowadays to try to generate some kind of baseline data, the simulators nowadays usually has a very, very steep learning curve. Some of them even require like master or PhD level of knowledge to run such simulations. And the simulators may not be ready to interoperate with each other. So sometimes you need to run simulations across different simulators to generate the output, and then you need to find a way to gel the output together. Also, there are long-term use cases we've seen which are quite new, and there are no existing simulators which were designed for that kind of scenarios just yet. So when the customers look around, they couldn't find a suitable simulators. Something need to be developed from scratch. So these are some of the examples I've listed down based on the learning points we've observed in the past few years from actual projects. I think this means both challenges and opportunities. So on one hand, we know that when it comes to digital twin creation, there are still a lot of gaps to be closed for data capturing. But at the same time, this means opportunities for companies like us, especially like smaller companies who may not be able to compete with big companies on those very established kind of projects. But then these smaller opportunities, the real very painful projects for our customers are usually a very good starting point for us to anchor our solutions. Next slide, please. Yep. So for this presentation, I've shortlisted 2 solutions we have developed so far, and I think later on we're happy to discuss with anyone who may have other ideas. This is one of the solutions we've developed. So one of our customers is actually an apparel manufacturing company. So their budget is usually, the procurement budget is usually not as high as some of the heavy industry customers we've dealt with before. They had this problem statement of not being able to track the location or the operating status of thousands of sewing machines within their manufacturing plant. And then when they look around in the world, the existing vibration sensors or location sensors are too expensive. They are beyond the budget they are able to afford at a point of time when they started talking to us. So for us, then we decided to help the customer to close this particular gap, to help them fulfill their wish list. So we actually design our own IoT sensor that is called Echo. So we come up with our own design for the PCB board, and we push that into mass production, right? We come up with a very unique design which helped to reduce the cost by basically compressing the overall data package when we track the location and the vibration of such sensors. So after we implement this solution to our manufacturing at our customer's manufacturing site, they are then able to track the real-time location of the sewing machines, as well as the vibration, the overall health status of their machines. This helps them to number one, look into the overall resources coordination in the real-time operations. So once they need to switch, once they need to shift one sewing machine to another production line, they can they are able to understand the overall operation efficiency, the overall operation status through digital twin very, very easily. And also the second point is that based on the vibration status we have captured across all the thousands plus sewing machines, you're able to understand the overall health status of such sewing machines. And we are able to perform the preventive analysis for our customers with this IoT sensor. So this is one solution, a particular IoT solution that we have innovated by ourselves to help our customers to close that digital twin overall data capture and monitoring gaps. Yeah, next slide, please. Yeah, and this is another example. So this is more for urban survey. So we understand that some of the customers wanted to conduct urban surveys and capture the locations of different objects of interest in the urban area. But sometimes they don't really have the list of items they need to capture upfront, right? So without the solution that we have provided, they will just have to keep deploying the manpower on site to capture such data. So when we came into this kind of project where we understand their problem statement, we basically come up with the GeoSense AI kind of solution. So the customers are able to capture the data based on the 3D models as well as the 3D cameras we've put up. Then we have provided this software pipeline where the AI-based automation will be able to help the customers to capture the object of interest and register that into the overall GIS system. So I think, Nuri, we'll just move on to the next slide. If later on we have some time, we may come back to this video. Is that okay? Yeah, okay, thank you. Yeah, so I just want to leave some final comments over here. Or rather, it's just a recap. So there are a lot of long tail data capture gaps in the market. Although digital twin has been such a buzzword in the last few years, I think at the most fundamental layer, data capturing gaps are still there. So for serious digital twin players, it may be a good idea to really use a customer-centric approach and try to really delve into the customer's processes and to try to address the root causes they are facing nowadays. A lot of times we notice that when the customers give us the problem statements, we still need to implement certain sensors at their facilities, and some of the sensors may not be readily available in the market. So these may be actually opportunities for smaller companies, SMEs, small and medium enterprises. And then this may also mean opportunities for collaborations, because it's impossible for us as one company to innovate all the different kind of sensors for the long tail use cases, but we could always collaborate with each other and see what are the data capturing solutions any of those players in the ecosystem might be providing, and we can go to market together. And the second point is regarding the overall innovation that many digital twin companies may want to consider. So I believe a lot of digital twin companies might originally be positioning ourselves as software companies, but I think increasingly we realize that we need to also equip ourselves with hardware expertise or the expertise with AI to be able to deliver a good solution, end-to-end solution to our end customers. So this may be one innovation direction that you guys might want to consider. And last but not least, while data capturing is important, which is also the main topic I want to share today, I think at the end of the day, we need to focus on spatial digital twins value, not just looking at not just in terms of its representational value, but look at its overall epistemic value. That means on one hand, we are trying to use the the digital twins to replicate the physical assets. But at the end of the day, it's the user who uses this that actually matters. It's the overall process of comprehending the target site that really creates the value in the end customers' overall processes. So I think these are some of the learning points we've basically gained in the last few years working on different kind of projects. And I think with that, we'll wrap up my very quick 15 minutes of sharing.
So our first question is, what is more precisely the role of AI in your day-to-day business?
So I'm not sure whether this question is asking about our business operations or the creation of spatial digital twins, but I'll try to address both. Right. So when it comes to the operations of a company, of course, there are certain tasks which we have automated. So for example, when it comes to project management, we actually rely on external tools to mark the tasks, and we're able to automate the solutions and send reminders to the respective person in charge within the project group. And also other tasks such as HR, like hiring of new hires. We also have some auto screening tools set up from our third-party HR platform. And as for spatial digital twin creation, I think again, I'm going back to the overall framework, level 1 to level 5, right? Actually, AI can be applied to every single stage of spatial digital twin creation. So when it comes to 3D creation, one example I mentioned was Gaussian splatting, which is basically a AI-based 3D generation based on 2D images. And when it comes to data interactions, the overall ETL, the extraction, transformation, and loading, you will know that there are solutions out there which allows user to use NLP to interact with the database and pull out the data accordingly. And when it comes to the analysis, just now I mentioned video analysis, which is also one very common plugin into spatial digital twin as well. When it comes to control, when we integrate the learning from digital twin into the fleet management system, for example, that is also considered one area of AI. So I think when it comes to the creation of spatial digital twins, AI is increasingly playing an important role in it. But we also should be aware of the limitations of such AI solutions. For example, Gaussian splatting, right? If the certain areas are not captured in the photo, then essentially you are relying on AI's guessing in terms of how that specific area look like, or the NLP I mentioned earlier. Although the language agent might try to translate the language into a SQL query as accurately as possible, it's still a good practice to keep the user in the loop so that they are able to verify the thinking process of AIs. So I've just talked about a few examples. I think there are a lot more examples out there, but at a high level, the overall principle would remain similar. We need to be aware of the limitations of how much AI can do nowadays. Yeah.
Perfect, thank you. And you touched on a bit there in your answer, the next question, but give you some time to answer more to this. Have you been able to exploit scan to BIM processes to develop 3D models incorporating AI?
Good question. So for scan to BIM, I think this is a relatively new area. So I'm based in Singapore. Some of the academic collaborators we work with from the universities, I know they are actually looking to better ways of doing this. We've had experience in the oil and gas sector where the customer had scan. So the output they need may not necessarily be a building information model, may not necessarily be in a BIM. What they need is a good process for scan to pipe. That means from the original PCD point cloud data into something that is more concrete, that comes with concrete meshes for us to then work with. So I think there are some solutions from some of those bigger players out there which are able to automate such solutions, and we are indeed using those solutions now. We still need to involve some form of a manual process in the domain, and yeah, so basically when we first pick up this, we had to learn that by ourselves. But once you kind of like get a gist of it, it's pretty easy to do. Yeah, so I hope that answers the question. Have we been able to explore? Yeah, we were trying, and we delivered solutions with that. But I think that overall speaking, there are still researchers exploring this direction to come up with better pipelines. Yeah.
Thank you. That's brilliant. Last question here is, for digital capabilities, they've taken the non-spatial approach first. How interoperable is your approach to now include spatial elements?
Great question. So I think conventionally there are a lot of solutions out there who may not really be spatial digital twins, but they would still be considered as a twinning, because when it comes to data, that is indeed still a replica of the target physical assets. Now, when we talk about interoperability from the non-spatial digital twin to the spatial kind of digital twin, actually one missing link is the it's how to set up this spatial database, the XYZ conversion, and that is exactly what we're trying to do with the spatial work platform. So what we're trying to do is to establish that XYZ conversion layer to enable the interoperability. If you recall, there's one slide in the deck just now which talks about the existing data capture solutions, and at the bottom I had this like very short line which talks about WMS, AMS, EMS. So the WMS, AMS, EMS are considered as the non-spatial type, and what we're trying to do is to bring that into the digital space. So that XYZ conversion needs to be done, and that is something that we're trying to do, something that we'll be focusing on, in fact.